Hi, I'm Simon. You've seen me in the videos already this week. And I've got with me Stephen Adams, who's the TA on the course.
And I've been commenting a bit this week, but we thought we'd come to you today, and at the end of each week we'll post a little feedback video talking a bit about what we saw in the comments and what's coming up next week. So there's a lot of comments out there, and it's really great to see, so keep doing that. And one thing that I saw some people talking about was why should we be learning Erlang? You know, there's a few big successes, but maybe it's a bit overhyped. We kind of trumpet the same 2 or 3 successes of the language, and maybe you'd like to talk about that.
Okay. Well, Erlang's been used in a lot of places. Of course, Ericsson use it, have used it very heavily, and are beginning to use it as well now. Other companies use it, particularly WhatsApp. But if you go, for example, to Erlang Solutions webpage, you'll see a whole number of customers that they've had, including in the online betting area, William Hill, Bet365, social networking area, EE in telecoms. So across a number of industries, we see Erlang being used. But I think there are 2 reasons for studying a programming language. One is to get to use that particular language. The second is to understand the principles that language embodies. And I think if you look at what Erlang embodies, it's about building robust, fault-tolerant systems, and doing that by having lightweight, share-nothing threads. That principle gets used in all sorts of different situations. I'm not sure it's entirely true, but it's clearly not. It's not entirely false either. There's an insight that if you look in a big enough messaging-intensive system written in C++ or whatever, what you will find in there is a re-implementation of the Erlang runtime. You'll see things about. You'll have the system's own threading system. You'll have mechanisms for fault tolerance and so on. And those are the things that Erlang embodies. Now, this particular MOOC is about functional programming, but that sits there as a foundation for building a robust, but very simple, very stripped-back concurrent language, which is what Erlang is. If you're interested in functional programming, there are lots of languages which are functional. Haskell is perhaps the most highly known at the moment. Haskell is lazy, which has lazy evaluation, gives you some advantages, some disadvantages. The key, I think, with a functional approach is that you get built into the language a notion of immutability. The fact that if you, are traversing a complex data structure, making modifications to it, if that data structure is shared between 2 different threads, you can have a nightmare of inconsistent views of the data structure. Whereas if you take an immutable view, you don't change parts of the data structure, you build a different variant of it, and you share the bits that are common. And this is what underlies what languages like Erlang and Haskell do, and what you have to do often for yourself in systems like Java in order to get good multi-thread behavior.
Yeah.
So the principles are there, and Erlang is a simple language. It's got a very small syntactic base, and therefore it's easy for you to take that in your stride and then understand the principles under there, the functional side and then the concurrent. So I think there are 2 sorts of justification for studying this particular MOOC and the MOOCs that follow this in Erlang, for the language itself, but also the principles.
Yeah. So the other thing that I think pops out very quickly to people that have programmed in other languages is Erlang takes a very interesting view of what exactly strings are.
Okay. And
kind of performance comes up a lot. Like, what are the performance trade-offs there, and what exactly is happening there?
Okay, I think if you go back to the evolution of Erlang, it was designed with the telecoms applications very much to the fore. So the first few versions of Erlang didn't have floating point numbers, for example. Just had integers. In a similar way, strings are appear in the language, but they're not a fully fledged data type. Strings are just a way of printing certain sorts of lists of numbers. And I think Erlang has this sort of Occam's razor. It's not Occam. Some of you may remember a language called Occam from a long time ago. But things are not included in a language just because it might be nice to include them. Things have to justify their presence in the language. So we can get what we want from strings, that is printing things out in the console, just by interpreting lists of numbers in a particular way. In a similar way, we can get the behaviour of Booleans just by saying that the two particular atoms, true and false, represent the Booleans. We don't need to have a separate data type.
And certain functions treat those atoms differently than they would
That's right.
other atoms.
Now, you could argue, there's a bigger argument to be had about whether Erlang's relatively freewheeling approach to types is the best approach, and there are arguments in both ways about that. Erlang lets you get started more quickly, you don't have to worry about type errors, but then it's arguably, in larger systems, type errors can perhaps be hidden and then come and bite you at a later stage. So the jury is out, I think, about that particularly. But I would emphasise that Erlang is, as I say, a stripped-down language designed with particular applications in mind. Going back to the question of strings, I would say that Erlang does have bit strings, and it has quite a sophisticated syntax for dealing with those. So, and this comes again out of the messaging sort of context, so that you can pull out sequences of bits from a bit string. You can do pattern matching over bit strings, and that allows you to write very compact, I think we'll see an example of this a bit later on in the course, very compact representations of protocols, saying pull out these 11 bits, do something with them, then pull out the next 13 bits, and so on. So that bit syntax and bit strings are there, are efficient, so features are included when they can justify their existence. So I guess one thing that we'll do in the on the web page for this particular step is we'll put some links to Erlang Central, which is an Erlang community site. You'll find some references there to jobs in various countries, various organisations, and also to Erlang Solutions. You can see companies they have worked for. The other thing I would perhaps conclude with is saying that the Erlang model is embodied in a number of different related languages. Mm-hmm. It's there in Elixir, which I'm sure you've heard about, which is a language that runs on the same virtual machine. It's library compatible with Erlang. Mm-hmm. It has a syntax a bit more like Ruby. And at the moment, Elixir is getting a lot of prominence. Knowledge of Erlang will help you understand Elixir. And finally, the Akka framework in Scala is pretty much a homage to the Erlang approach, but built in Scala, which of course runs on the JVM. So there are these sorts of messaging, concurrency-intensive applications appear in other languages than Erlang. Yeah. So again, it will be a skill which will be of value, not simply in the Erlang community, but way beyond that. Okay, next week, what we're concentrating on are lists, because they're the kind of workhorse data type in Erlang. We use those for all sorts of different things. And
well, in all functional languages, really. That's
true.
Quintessential data structure.
That's true, yeah. No, you're exactly right.
Yeah.
So we'll be seeing how those work, learning how to program on those, learning particular patterns, which in the final week of the course, we'll show are actually embodied in higher order functions, mm-hmm. which, for example, embody transforming every element of a list in a particular way, or selecting elements of a list with a particular property. Mm-hmm. But that's for next week and the week to come. So goodbye from us, and we'll see you next week.
All right.
Thanks very much.